Hi everyone, Miss Lorette here. I'm going to be continuing section 6.2 in this video. I'm going to walk you through lesson 2. We're still solving systems using the substitution method. We're going to take a look at some word problems in this lesson. So when you're using the substitution method, typically the way that a word problem is going to give you the linear equation, they're going to give it to you in slope-intercept form, usually. And remember that this is the form y equals mx plus b. So they don't always give it to you in this form, but more often than not, it's typically given in this form, and then that's your clue that substitution is going to work best for that word problem. So there's two things that the word problem is going to give you for each equation if it gives it to you in this form. They're going to give you a slope, and they're going to give you a y-intercept. So some things to look out for to know which number represents each thing is going to be the following. Here's some things to look out for to know that you've been given the slope. So you've been given your m value if you're given some sort of a rate. Some words and phrases to look out for to know that you've been given a rate would be words like per or each or for every. So for example, let's say you were depositing money into a savings account and you were depositing $50 per week or every week. That would be your rate. So in your linear equation, if you used a linear equation to represent the amount of money in your account, the $50 would be your slope. For your y-intercept, some things to look out for, this is how you know you're given a y-intercept, is if you're given some sort of initial or starting amount. That's going to represent your b value. So again, if you were thinking about the amount of money deposited in a savings account, let's say you already had $100 in that savings account. You started with $100, that's your b value, and then you're going to deposit $50 each week. That's going to be your slope. So keeping all of this in mind, we can use these strategies to help us write systems of linear equations and then solve it using the substitution method. So let's take a look at this example, and I'll walk you guys through a couple here, and then I'll let you try one. We've got a couple of candles. One of the candles is 9 inches tall and the other candle is 7 inches tall. The taller candle burns at a rate of 1.15 inches per hour. So they're giving us a rate. That's important information. The shorter candle burns at a rate of 0.75 inches per hour. So that's another rate. After how many hours will they be the same height? Explain your reasoning. Okay, so the first thing that we should do in each and every word problem is we should define some variables. And typically the variables that we use when we're writing a linear equation is x and y. So if you've covered chapter 4 in my class, then you would have learned the difference between an independent and a dependent variable. And this is typically what we're going to use to help us identify which one's y and which one is x. X is going to be our independent variable. It's the thing that we can't change. And then y is going to be the thing that depends on the x. So this is our dependent variable. So my two variables, I can actually look at my rates to determine what my two variables are. I've got inches as a variable and I've got hours. So we've got time and we've got inches. So think about it. Which one depends on the other? Does the height of the candle in inches depend on the number of hours it's been burning, or does the time depend on the height? Well, you can kind of think about it logically. We can't control time. That's always going to be independent. So the inches is going to be dependent and the hours will be independent. So I'm going to say let x equal the number of hours, and therefore y is going to be the number of inches. I'm just going to move this a little bit closer. There we go. Well, they're giving us rates, right? We've got two candles, so we're going to have an equation for each one. So we're going to have two different equations. We've got a taller candle and a shorter candle. So we've got a tall candle and we've got a shorter candle. Each candle is going to have its own linear equation. Well, the rate is giving us the slope. But we have to stop and think about what the sign of our slope would be. Not every single word problem is going to give you a positive slope. And it's also not going to explicitly tell you when it's negative. You kind of have to think about it logically. If the candle is burning, is it gaining inches over time or is it losing inches over time? Well, I know that if the candle keeps on burning, it's going to get shorter and shorter and shorter. It's losing height. So that's actually a negative slope. Okay, so this is a negative slope. It's giving me a slope and it's negative. And it's negative for both of them. They're both losing height over time. The tall candle is burning at a rate of 1.15 inches. So I can start by writing my linear equation y equals negative 1.15 x. And then I need my B value. Now remember, the B value is going to be some sort of starting amount. Well, if I look at the picture here, it's telling me that this candle was 9 inches to begin with. That's my B value. Here are both of my B values, the initial height of the candles. So this is going to be negative 1.15x plus 9. For the shorter candle, it's burning at a rate of 0.75 inches per hour. So again, that's a negative slope. It's losing height over time. And that candle's initial height was 7. And I'm using a positive here because this is a positive height. Okay, so it's plus 9 and plus 7. Once we have our linear system, which is the hardest part, I can use the substitution method. I can take this expression and substitute it for the variable in the other equation. And it doesn't matter which one I do. I could take this algebraic expression and substitute for the second y, or I can take the second algebraic expression and substitute for the first y. Each of these things are equal. This expression equals y, so I can interchange them here. Now, when I do this, I should only have one variable. And in this case, I'm only going to have x's. And I can attempt to solve for the x. I'm going to collect my variables to the same side. I'm just going to add this 1.15x to each side. I'm going to bring my 9 down, and I'm just going to use a calculator really quick to work that out. So 0.75, but I got to make sure that I make it a negative. That's going to give me positive 0.4x, bring down my plus 7. At this point, it's just a simple two-step. I'm going to subtract the constant away. I'm going to divide both sides by the coefficient, and that should give me positive 5. Okay, so now I need to go back and double check, have I answered the question? I didn't get the y variable. I could if I substitute that solution back into one of these equations, but before I do that, I'm just going to go back and reread the question because I might not need it. It says, after how many hours will they be the same height? So it's looking for the number of hours, which is what my x is. I've got that answer. It is not asking me to provide how tall the candles would be. I don't need to waste the time substituting the solution in and solving for the y. I'm actually done here when I find the x. So it says, after how many hours will they be the same height? So I'm going to write it in words. After 5 hours, the candles will be the same height. So we didn't even need to find the y. So just something to keep in mind when you're doing a word problem. Read the question carefully. Sometimes you don't have to find both variables. Sometimes you only need one. Let's do another one. Janet wants to buy a charm bracelet. Oakdale Fine Jewelry charges $20 per charm plus $36 for the bracelet. Kramer Jewelers, in contrast, charges $12 per charm and $44 for the bracelet. If Janet wants to add a certain number of charms to her bracelet, the cost will be the same at either jewelry shop. How many charms would that be? What would the total cost of the bracelet be? So again, the first thing that we should always do is define our variables. And remember, x is our independent variable and y is dependent. So I can kind of go back 20 per charm. So that's giving me a rate right there. And it's also telling me that I've got two variables. I've got money and I've got numbers of charms. So which one depends on the other? Does the money depend on the number of charms, or does the number of charms depend on the money? Well, the price that Janet is going to pay is going to depend on how many charms she gets. So that means the number of charms is independent, and then the money is dependent. The amount of money depends on the number of charms. Typically, when you're looking at a word problem and one of your variables is money, that's typically your y variable, okay? And if you're looking at a word problem and you have time as one of the variables, we don't here, but in the last one we did. But if you see time as a variable, that's always going to be your x. So some things to keep in mind. These word problems get easier with practice. Okay, so we've got two jewelry stores. We've got Oakdale Fine Jewelry. I'm just going to abbreviate. That jeweler is going to have its own linear equation. We also have Kramer Jewelers. That jewelry store is going to have its own linear equation. And again, going back to this problem, this rate of 20 per charm, that's my slope. And this rate of 12 per charm, that's the slope for the other jeweler. So this 36, this fee, this flat rate of 36, and this flat fee of 44, those are the b values. Those are the y-intercepts. Once I know all that information, I can write a linear equation for each place. Oakdale Fine Jewelry is y equals, they're charging 20 per charm, so that's my slope, 20x, plus 36, so that's my b value. Kramer Jewelers is y equals, and they're charging 12 per charm, so 12x, plus 44 is my b value. Once I've got my system, which is the hardest part, I can take this expression, which is equal to y, and replace the y in the other equation. And again, I could have done it the other way. I could have taken this expression down here and substituted for the y up here. It doesn't matter. You should get the same answer no matter what. So I'm just going to set them equal and solve for my x. Subtract 12x to get my variables to one side. Subtract the constant to solve the two-step. Let's see, 44 minus 36 is going to give me 8. And then divide to solve the one-step. X equals 1. Okay, so again, before I solve for the y, I'm just going to double check to see if I already have my answer. X is the number of charms, and it did ask how many charms would that be, but then it also asked what would the total cost of the bracelet be. So this is asking for the amount of money. So I do actually have to go back, use this solution to solve for my y, and I can use my solution in either of these equations. I'm just going to use the top one. So I have to go all the way and solve for the y. It's not very many charms on her bracelet if she's just getting one. Okay, so I substituted 1 for the x, I multiplied, and now I'm going to add, and that's going to give me 56. That's an expensive bracelet for just one charm. Last but not least, I just have to write some sort of final statement using this information. So she's going to get one charm, and she's going to spend $56. So it would be one charm, the total cost would be $56. Here's one for you to try. So I encourage you to pause the video here and then give it a try, and then I'll show you the solution on the next page. Okay, so hopefully you've given that a go. So the word problem says Mr. Klein and Miss Kim are teaching their classes how to write in cursive. Mr. Klein has already taught his class 3 letters and plans to teach his class 4 new letters per week. The students in Miss Kim's class currently know how to write 12 letters and intends to cover 3 new letters per week. Eventually, the students in both classes will know how to write the same number of letters. How long will it take? How many letters will the students know? So they're asking us 2 questions here. So they actually do want both variables in this word problem. First thing I did is I defined my variables. Remember, weeks is time. If you have time as one of your variables, that's always going to be the x. That's always your independent variable. We cannot control time. It is always independent. Therefore, the number of letters will be our dependent variable. For Mr. Klein, his rate is 4 new letters per week, so that's my slope. And they already know 3 letters, so that's my starting value, so that's the b value. For Miss Kim, her rate is 3 letters per week, so that's the rate, that's the slope. And then the 12 was the starting amount, so that was the b value. I can take this algebraic expression 4x plus 3, since it's equal to y, I can replace the y in the second equation with it and solve. When I solved, I got x equals 9, and then I used that solution to solve for y. So it will take 9 weeks, and the students will know 39 letters. So this is more letters than what's in the alphabet. So I'm assuming this is both capital and lowercase, probably. Let's take a look at another example. This is an example of finding a break-even point. A fashion designer makes and sells hats. The material for each hat costs $5.50. Okay, so each hat, so that's a rate. And then the hats sell for $12.50 each. The designer spends $1,400 on advertising. Okay, a one-time payment. How many hats must the designer sell to break even? So a break-even problem typically is going to give you an expense equation and an income equation. So in order to break even, your expenses and your income must be equal. So let's start by defining our variables. We have an x and a y. So number of hats is definitely one of my variables, and then money is the other. Okay, so the amount of money that's either spent or earned, depending on if it's expense or income, it's going to depend on the number of hats. Okay, so again, money is typically our dependent variable. It's going to depend on something. So that means x has to be the number of hats. So we've got some values that represent a cost or an expense, and we've got some numbers that represents what the designer would get as income. It says that the hats sell for $12.50 each. That means that the designer is getting this as income for every hat that is sold. Okay, so we've got an expense equation and we've got an income equation. That's the way to look at these break-even examples. So let's see if we can find a rate for our expenses. So it says the material for each hat costs $5.50. This is an expense rate here. It's $5.50 per hat. So this is my slope, but it's my slope for my expense equation. Then we're told that each hat sells for $12.50. Again, this is income. This is what the designer would get for every hat that is sold. So this is also a rate. This is my slope, but it's my income slope. We're then told that the designer spends $1,400 on advertising. This is an expense. So this is a B value for my expense equation. We are not given any more information, so that means that our B value for our income is 0, okay? So what this is essentially saying is that we don't already have an amount of income. We have 0 income, and then we get $12.50 per hat. So now that I have my system, I can take this expression, which is equal to y, and substitute it for the y in the other equation. I'm going to collect my variables on one side. I'm going to be left with 1,400 equals, let's see, 1250, so that's going to be 7x, I believe. Let me just double check my mental math. It's late in the day here. Don't want to make any mistakes. Good. It is 7. Now I'm going to solve the one step by dividing both sides by 7. And I get 200. Okay, so 200 hats. So I'm just going to go back and double check. Do I have all the information that I need? It says, how many hats must the designer sell to break even? So all we care about is the number of hats. All we care about is our X variable. We don't really need the Y variable. So I'm actually done here after I have X equals 200. So in order to break even, the designer must sell 200 hats. Here's one for you to try. It's another break even. So again, think about income versus expense and give it a go. Consider pausing the video and then unpausing, and then I'll show you the solution. Whoops. Okay, so here's what I'm getting for my answer. It says a puzzle expert wrote a new Sudoku puzzle. His initial costs are $8.64, so that's an expense. Binding and packaging each book costs $80. Okay, so it's a cost, so it's an expense. It's also a rate, so this is a slope. The price of the book is $2. So it's not really explicitly telling you that this is a rate, but it actually is. Okay, so the person who wrote the book, what this is saying is that he is selling this book for $2 a piece. Every book that he sells, he's going to get $2. So this actually is a rate. How many copies must be sold to break even? So again, we want to define our variables. Money is going to be our dependent variable. The amount of money depends on the number of books. We have an expense equation and an income equation. Our expense equation, we were told that the initial cost, so that's a B value, and then also we were told that each book costs 80 cents to make. So it does cost money to make these books. So that's our rate, so that's our slope, 0.80x plus 864. So we're going to try and offset those costs for making each book by charging $2 for each book. So again, it's not as clear here, but that is a rate. This is our income. This writer is going to get $2 for every book sold. Once we have a system, we can set this algebraic expression equal to this y, since it's equal to y, and solve for x. When I solved, I got 720. And again, all we needed was the x. We only cared about how many books needed to be sold. We didn't care about the amount of money at the end of this problem. So hopefully we match there. These problems do get a little easier over time. It's a little tricky at first, but as you do enough of them, you start noticing patterns. Let's take a look at this one. Identifying constraints and viable solutions. It's important to kind of question the validity of your answer. Does it make sense in the context of the problem? The local zoo is filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? Explain. So again, I'm going to start by defining some variables here. Let x equal, y equal. So we've got 2 variables. We've got numbers of gallons and hours. I know that the number of hours has to be my x. That's my independent variable. Time is always independent. So that means y has to be numbers of gallons. So we've got 2 tanks. Tank 1 and tank 2. Tank 1 already contains 50 gallons of water. That's my b value. And then the rate is my slope. And it's being filled at a rate of 10 gallons per hour. So this is a positive slope. So 10x plus 50. And then for tank 2, it already has 29 gallons of water and it's filled at a constant rate of 3 gallons per hour. So again, that's being filled, that's additional water, so that's a positive slope. Now that I have my system, I can take this expression, which is equal to x, it's equal to y, and I can substitute it for the y in the other equation. It's going to create a multi-step equation. I'm going to bring all my variables to one side. I'm going to subtract the 3x. That's going to leave me with 7x plus 50 equals 29. And now it's a 2-step. I'm going to solve by subtracting 50. 29 minus 50 is going to give me negative 21. So I've got 7x equals negative 21. And I'm going to solve the 1-step by dividing. And I get x equals negative 3. So let's think about this for a second. I'm getting a negative solution. I am getting an answer, but let's think about what that x represents. It's the number of hours. So when will the 2 tanks have the same amount of water? Well, can you have a negative amount of time? And the answer, of course, is no. So in this case, when will the 2 tanks have the same amount of water? Never. It's never going to happen. It's not possible. The answer that we're getting does not make sense. It is not a viable solution. So we're going to refute that as an answer. So I'm going to write as my final answer, the 2 tanks will never have the same amount of water. And my explanation is you can't have a negative amount of time. Time can't be negative. This answer does not make sense, so it is impossible. Here's one for you to try. Again, we've got some zoo tanks. So I encourage you to pause the video, give it a try, and then I'll show you what I'm getting as an answer on the next page. All right, so here's what I'm getting. Again, we're going to say X is the number of hours and Y is the number of gallons. Now in these two examples, you really want to be careful. Our slopes should be negative in both of these equations. The water is leaking, okay? So we're losing water. So these are negative slopes. We had an initial amount of 10 gallons, and then it was leaking at a rate of 2 gallons per hour. So here is the linear equation for that. And then the next one already had 6 gallons of water and was leaking at a rate of 4 gallons per hour. I can take this algebraic expression, which is equal to y, replace the y in the second equation, and solve. If you set up your system correctly and you solved for x correctly, you should have gotten x equals -2. So again, think about what this means. This is number of hours. We can't have -2 hours. It's not possible. So again, the tanks will never have the same amount of water. That is not a viable solution. Time can't be negative. So I know that these word problems can be a little bit challenging, but like I said, it just takes some practice. If you do them enough, they start getting a little easier. So as always, if you guys have any questions, please reach out to your teacher. I hope these problems were helpful to you, and I will see you guys next time.